Hi everyone. This is the first practice problem for section 5.2. And it's a little bit tricky, so I want to take the time to really connect it back to what you learned in 5.1. So it says, using a right endpoint Riemann sum, which of the following represents the limit definition of the definite integral from 5 to 14 of 4x squared dx? This was a multiple choice question in Newton, and I just kind of took off the choices. We're just going to solve it. So the limit definition for this starts off with the limit as n goes to infinity of the sum of I equals 1 to n of f of x sub I dx. So I want to kind of explain this as we go. So imagine that this is the x-axis. And we are evaluating this interval, or this function over the interval from 5 to 14. And we are going to partition this interval up into n rectangles. And then we're going to take the limit as n goes to infinity. So I'm going to put like a little dot, dot, dot here to show that we have an unknown number of n rectangles. So this first x value where our interval starts, this is x sub 0. The next one would be x sub 1, x sub 2, all the way up to x sub n. These subscripts are the i's. So this would be I equal to 0, I equal to 1, I equal to 2, and so on, all the way up to I equal to n. So I want you to see now that since this is a right endpoint Riemann sum, that looking at this first rectangle, the height of this rectangle would be where x sub 1 is evaluated into the function, which means that's when I equals 1. For the very last rectangle, it's where the right side is at x sub n, or I equal to n, which is why our summation goes from 1 to n. If this had been a left endpoint Riemann sum, we would have gone from 0 to n minus 1. So now I want to talk about the width of our rectangles. So the width here, this width of our rectangle, this is called delta x. And to find this delta x, we take the length of the interval and we divide it by how many rectangles we have, which in this case is n. So delta x, I forgot the x. Delta x is going to be the width of the width of the interval divided by the number of rectangles, or 9 over n. Now I want to talk about x sub I. So let's say we have this interval in the middle here. At some point, we'll call this x sub I minus 1 and this x sub I. Then the right side here is going to be that x sub I. So we're going to evaluate that into the function to find the height of our rectangle, which was why this says f of x sub I. But we want to figure out what that is with respect to our 5 and the width of our rectangles. So at x sub 1 here, if we wanted to find this next value, if the width of the rectangle is 9 over n, then this next value is 5 plus 9 over n. And then if we wanted to find the next one, this would be 5 plus 2 times 9 over n, right? We add 9 over n again, and we would just keep adding 9 over n. So to get all the way to this x sub I, we're taking 5 plus I times 9 over n, which means that we can write x sub I as 5 plus I times 9 over n. And We're going to find a common denominator here because that's what Newton wants us to do really badly. So this is going to be 5 plus 9I over n. And I can then write this as 5n over n plus 9I over n, just finding that common denominator, meaning that x sub I then is going to be 5n plus 9I all over n. So now that we have delta x and we have x sub I, we can now plug this information in. So going back to the limit, we have the limit as n goes to infinity of the sum as I equals 1 to n of f of x sub I, which we determined was 5n plus 9I all over n, times delta x, which we said was 9 over n. Well, if we put this 5n plus 9I over n into the function is 4x squared, this is going to give us the limit as n goes to infinity of the sum from I equal 1 to n of 4 times 5n plus 9I over n squared times 9 over n. And all we really need to do now is clean this up a little bit. And again, this is a multiple choice question, so you'll be able to kind of match it up with what they're looking for. But I'm going to distribute this squared to the numerator and the denominator and pull out the coefficients and the ends. So we have the limit as n goes to infinity of the sum of I equals 1 to n. We can write this as 4 times 5n plus 9I squared over n squared times 9 over n. And now 4 times 9 is 36. So we can pull the 36 out. And then in the denominator we have an n cubed. So we can pull that out. And left we have the sum as I goes from 1 to n of 5n plus 9I squared. And that is our answer.